Hello. Didn't see you there. All right. Welcome to the UO lab. We've been operating the Big Red Skid for an hour under program control. And now we'll show you how to do it.
So we've just gathered data for our FCV loop from the Big Red Skid. Our lab members are tired of operating in manual operator mode, so we want to automate the controls. To do that, we need to calculate key parameters for our tuning rules. We'll be using the Cohen-Kuhn tuning rules. We'll first calculate the process gain. So gain is the ratio between the change in output and the change in input. During our step testing, we've increased and decreased the percentages of our CV in our Fisher flow control valves. This gray curve represents the change in input and the change in input in our CV. We then recorded the change in values of our flow indicating Coriolis transmitter provided by Emerson. Thank you, Emerson. So this blue curve represents the change in our flow transmitting values. So we can then calculate the different process gains. We can also see in the trends the delay between the input change and the output change, and also calculate the time constant based on the first order lag transfer functions. These parameters will help us automate the Big Red Skid.
Here we have Unit 1 of the Big Red Skid. This is PCV11, which controls the outflow of air from the stripper column. Our set point is 20 psi, and this set point is maintained by using PI control. Here's our proportional gain, and here's our integral time. On this side, we have FCV11, which, unlike the PCV11, which is in program control, FCV11 is in cascade control, which means it works off of a ratio measured by FIT12. Right now, the set point is always 0.12 times the standard cubic feet per minute flow rate of FIT12. The controller gain and the integral time were also set for the PI control for this loop. Moving to Unit 2, we have the temperature control loop, which has a much higher gain as well as an integral time. And the set point we have chosen to be 100 degrees Fahrenheit. The LCV21 loop has also been controlled using PI. Our proportional gain and our integral time are shown here. And the set point has been chosen to be 23 inches. In Unit 3, we have no tuned loops, but here we have the fan, which hasn't been running as of yet because it has not reached the high set point, and the pump is still going.
Close FCV11, CV to 0%. All right, I see that the CV's been at 0%. So now we gotta wait for the level to be less than 2 inches.
I have to open LCV11.
Okay, open LCV11. All right, LCV11 is open.
Level's getting down.
As soon as the the level is less than 2 inches, shut down the compressor.
Okay, shutting down compressor.
All right, the compressor is off. So let's work on Unit 2 now. So let's turn off the heater.
Turning off heater.
Close FCV21.
Closing FCV21.
All right, FCV21 is closed. Let's make sure that the LCV21 is at 100% open so that we can drain the level to less than 1 inch.
LCV21 at 100% open.
All right, LCV21 is at 100% open. Level is draining, that's good. As soon as the level drains to about 1 inch, go ahead and close the LCV21.
Okay.
All right, LCV21 is closed. Let's do unit 3. We got to turn off the M31, the pump.
Turning off the pump.
The pump is closed.
System shutdown complete.
Copy.